Hello everyone, welcome you all to the new lecture series State Space Analysis. So in this video we are going to deal with state transmission matrix. Let's begin with the basic ideas of state transmission matrix. So I will explain it by using the upcoming slide. State transition matrix, we can define it by means of how the system state evolves from the initial conditions over time. It connects the system present states to its initial states under zero input conditions. So in simpler term, it tells us given where the system started, where it is now. And it's essential for analyzing the system behavior, especially for accessing the stability, controllability, and responses over the time period. And in the next slide, we are going to see about the mathematical representation. Mathematically, for a linear time invariant system, the system can be represented in the state space as x dot of t, which is equal to a into x of t plus b into u of t, where the x dot of t, which is the derivative, or the x of t with respect to t, whereas A is the system matrix, B is the input matrix, and as we all know, U is the controlled input vectors. So from this, we can tell the state transmission matrix, which is phi of t, which is equal to e power at. Here, A is the system matrix, and again, x of t is the state vector. It can also be derived using the Laplace transform, that is phi of t, which is equal to L inverse of Si minus A the whole inverse. This expression incredibly uses for solving state equations and modeling real-time system responses. Next is the steps to evaluate the state transition matrix in a structured way. So we are going to see that in step-by-step process. So in the step 1, we are computing Si minus A, where I is the identity matrix. In the second step, we have to find its inverse, that is Si minus A the whole inverse. In the third one, apply the Laplace inverse to obtain phi of t. This process provides us the time domain behavior with the system from its matrix model. For simpler matrix, we can use the series expansion as well as diagonalization to track the system for the alternative methods. Next, we are going to see about the properties of state transition matrix. Let's now explore the key properties of this state transition matrix. First one is invertibility. So phi of t is always invertible, which allows us to trace the system behavior backward in the time. Next, we are going to see about eigenvalues connections. That is, the eigenvalues of matrix A directly influences the phi of t and represents the poles of the system. Next one is the independence, which means the independence from the initial conditions, that is phi of t, which is determined purely by A, not by x of 0. Last one is the time invariance, that is phi of t1 plus del t, which we can represent it as a phi of t1 multiplied with phi of del t, which means we can calculate evaluations in these segments. So continuing to the properties of state transition matrix, we have few more fascinating properties, which is linearity, that is the matrix respects the superposition principle if x1 and x2 are solutions, so which is ax1 plus bx2. Next is the deterministic evaluation. Once the system is defined, its evaluation is predictable and governed entirely by the phi of t. Next one is the inverse property. So in the inverse of phi of t, which we are naming it as phi of minus t, reflecting the time reversal. Next is the initial identity, that is phi of 0, which is equal to I, which is the identity matrix. Since the time 0, the system is unchanged. Last one is the power rule, that is phi power k into t, which is equal to phi of t power k, which is useful for stepwise integration in these simulations. So these properties will help us to identify the stability as well as the state transition matrix behaviors. To summarize the state transition matrix, which is a cornerstone in the analysis of linear system, and it helps us to predict how the state evolves, analyze stability, and solve the differential equations effectively. This wraps up the sessions on phi of t. In the next video, we will discuss in detail about this state transition matrix along with the designing controllers. I hope you have understand some of the concepts of state transition matrix and properties. So let me introduce some other interesting topics in the upcoming videos. Thank you.